Hello students, welcome to my channel. In this video, I am going to discuss about potential energy of a system of charges. That is, electrostatic potential energy of a system of charges. How a system of charges will possess a potential energy or electrostatic potential energy? So we will see it. So I am going to consider it a system like this. How I will be going to consider if it is a triangle like this, is that okay, and this point I need to consider q charge. I need to consider say construct here q and q. This is a system of charge. What is system of charge means? Is a what number of charges, or single charge also we can consider a single charge system. Okay, so I need to make these charges are in this distance like this. What I have to do? First I will bring this charge here. Okay, so then I am going to bring next to this. If I will bring the next to this charge, what will be happen? These will be trying to repel this. So have to do a external work. Okay, so here what is there? A electric field is there. So next I have to do, I have to bring this. So these two will combinedly oppose to bring this, because these are all three are same charges. Clear? So I have to do a work against this electrostatic field of these two charges. Okay. So we already studied as work done against any force, that is work done against a conservative force, is to be stored as a potential energy, or potential energy will be changes. Potential energy of the final minus potential energy of finish. If it is to be this is the work done by the conservative force. If this is the work done by the external agency, that work done is equal to change in potential energy. That means final potential energy minus initial potential energy. So that means to construct a system, the external agency has to do a work. That work done is stored as the potential energy in that system. Okay, like this. Here, what is the conservative force? The electrostatic force. Okay, so this q charge has to bring here. First we will bring this, then this, and then this. After bringing the second charge, the external agency has to do a work against this electrostatic conservative force. That work done is stored as the potential energy of this system. And again this also we will bring, means again we have to do a work done. So that work done also are added in the system, and these work done will be stored as the potential energy of the system. So we can define it as potential energy of the system. Potential energy of the system is the amount of energy stored when work done by the external agency to build this configuration. Building the configuration. Building the configuration. Clear? Okay. So we can define it as potential energy of a system is the amount of energy when the work done by the external energy to build the configuration. Okay, to building this configuration, how much is the work done the system? That work done is to be stored as the potential energy of the system. Clear? Okay, that is about the potential energy of the system of charges. So now we are going to define, or we are going to find potential energy of the single point charge system and 2-point charge system and 3-point charge. First we are going to see about potential energy of the single point charge system. Potential energy of the single point charge system. What do you mean by single point charge system? That means in that system only one charge is to be there. That is the single point charge system. Okay. So here what we are going to do, we have to bring a single point. Okay. Single point charge. That means you can consider like this. Here is the origin. Here is a point 1. In this point 1, I have to bring a charge. For this, we have to consider 2 assumptions. First thing is, we will consider it as all the charges are initially at infinity. What is the first assumption? All the charges are initially at infinity. And the next assumption is, we are bringing, or external agency is constructing the system by bringing each charges 1 by 1 by 1. That means we are not bringing the charges together. We are bringing the charges 1 by 1 by 1. Okay. So I need to consider what type of system? Single point charge system. Okay. So what I have to imagine, initially my charge is at where? Infinity. So this is my point of infinity. There is my charge Q1 is there. Okay. So I need to bring this Q1 to here. Okay. So I need to bring this Q1 to here. What I have to do? Is there any work done I have to do? Work done to bring this Q1 from infinity to 1 is equal to what? Changing potential energy. Okay. Clear? Here I have to do any work done. If I have to, or external agency has to do a work only if there is an opposing force. Here, there is no external field is there. There is no external field to oppose these charges to come here. So, we don't need to do any work done. So, here, work done to bring the charge is to be 0. So, potential energy of the system is what? Potential energy of the system is to be 0. Clear? Potential energy of the 1 minus potential energy of infinity. So, potential energy of this system is to be 0. U1 is equal to 0. Clear? Okay. So, we will consider the system like this, single point charge system. That means there is a, here we can draw it. This is the origin. This is a point 1. This position vector is R1. Okay, here there is a charge Q1 is there. What is the potential energy of the system? Potential energy of the system is to be 0. Because there is no external electric field is to be present here. Only this charge is there. So, potential energy of the system is to be 0. Next, potential energy of a 2-point charge system. Okay, what is this 2-point charge system is to be like this. Clear? There is a axis, there is an origin, there is a point 1 is there, its position vector is R1, there is a position point 2 is there, its position vector is R2. Okay, I need to construct this system. Okay. So, what is our assumption? Our assumption is all the point charges are at where? At infinity. Okay. And we have to bring 1 by 1. So, first I will bring what? First I will bring this Q1. This is my point of infinity. From this infinity, I will bring Q1 to here. Okay, I will bring Q1 to here. Is there any work done I have to do? So we will study that work done to bring Q1 from infinity to point 1. 1 is what? Is work done W is equal to infinity to 1 is equal to what? 0. Why it is to be 0? Because there is no electric field is there. So external agency has to do no work. Okay. Then so now my Q1 is at where? At this position. So this my system is to be like this now. So origin, this is a point 1. At the point 1, what is there? Q1 charge is to be there. Okay, position vector is R. Now what I need to do? In the point 2, I have to bring what? Q2 charge. Where is my Q2 charge? My Q2 charge is at infinity. This is the point of infinity. From this Q2, I have to bring. This Q2 I have to bring from here to 2. So what I have to do? We have to do a work done. Why we have to do a work done? Because this Q1 will produce an electric field at this point. Okay, so the distance between these 2 points is R12. How will you calculate R12? Final position minus initial position vector. Okay, R2 minus R1 you can find out. By using that you can find out R12. So now I am going to find out work done to bring Q2 from infinity to point 2. Okay, so work done to bring Q2 from infinity to the point 2. Okay, clear? So work done infinity to the point 2 is equal to how much? Potential energy of the final position. What is the final position? 2 minus initial position is infinity, 0. Potential energy of the infinity is 0. So work done to bring infinity 2 is equal to potential energy at the point 2. Potential energy is equal to what? Potential energy is equal to potential into charge. What is the potential at the point? That is V2 into what is the charge we are bringing, that is Q2. Clear? What is the V2? V2 is the potential produced by this Q1 because only Q1 is there. So how much is V2? V2 is equal to 1 by 4 pi epsilon 0 Q1 divided by point to this distance, that is R12. So we will get it as U2 is equal to 1 by 4 pi epsilon naught Q1 R12 into Q2 you will get. So we will get it as 1 by 4 pi epsilon naught Q1 Q2 divided by R12. Clear? Okay, so what is the total work done? This is the work done to bring second charge. Okay, clear? Work done to bring Q2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Clear? So what is the potential energy of the system? Potential energy of the system is the work done to bring work done to construct the system. That means work done to bring Q1 and Q2 together. So total work done is equal to how much? Work done to bring Q1 from infinity to 1 plus and work done to bring Q2 from infinity to 2. Okay, clear? So what you will get? So total first work done is to be 0 plus this is the work done 1 by 4 pi epsilon naught Q1 Q2 divided by R12. So potential energy of the 2-point charge system is how much? 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Generally we can say that what? 1 by 4 pi epsilon 0 into that Q1 into Q2 into what is the distance between them. Okay, clear? Like that. That is the potential energy of a 2-point charge system. We have to, if you want to draw this 2-point charge system, we can draw it here like a small diagram. Here this point 1, what is there? Q1. This is to be the position vector R1, and here is the point 2. Position vector is R2. Charge is to be Q2. Clear? Okay, and the distance between them is R12. Clear? This system, potential energy possessed by this system is this. U is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Clear? Okay. Next we are going to see about potential energy of the 3-point charges. Now we are going to see about potential energy of a 3-point charge system. Clear? Okay. So what is a 3-point charge system? So I am going to see about the 3-point charge system. This is the point 1. This position vector is R1, and another point 2 I am going to consider. This position vector is R2 and 2. This is clear. And there is another point. This is the point 3, and this position vector is R3. Okay. So I need to build this system. Okay, I need to build this system. Here I need to bring it. So initially what we have to consider, all the charges are initially at infinity, and we are bringing the charges one by one we have to be bringing. Okay, so first we are going to study about work done to bring Q1. So my Q1 is at infinity. So I have to bring this Q1 from infinity to the point 1. Clear? Okay. So work done to bring Q1 from infinity. Bring Q1 infinity is how much? Equal to 0, because there is no agencies to oppose this. So the work done needs to be 0. Okay, clear? Next. This is the point R1, 1. At point 1, now Q1 is to be there. Okay, this is the R2 position vector for the point 2, and this at the point 3 have a position vector R3. Now I am going to bring Q2. My Q2 is at where? At infinity. So this is the Q2 point charge. It is at infinity. I have to bring it this point. In this point, the distance between this point is R12. Clear? Okay, so work done to bring this Q2 from infinity to the point 2 is how much? Potential energy at final position, that is 2 minus potential energy at infinity. Potential energy at infinity is to be 0. So work done to bring Q2 from infinity to is equal to U2. Okay, so how much is this U2? U2 is equal to charge into, what charge we are bringing? Q2 into potential at the point that I am to be considered as V2. What is this value? This value is the potential produced by the Q1 at this point. So we can get it as 1 by 4 pi epsilon 0 Q1 Q2 divided by R12. Okay, 1 by 4 pi epsilon 0 Q1 divided by R1 is the potential produced by this Q1 at this point. That we name it as V2. Okay, this is the work done. Okay, clear? Okay, next we are going to find out work done to bring the third charge. Okay, now our system is, how it is our system? This is the point 1. R1 is the position vector, Q1 is there. At the point 2, R2 is the position vector, Q2 point is there. Okay, now we need to bring at the position 3, having a position vector 3, we have to bring a Q3 charge. Okay, Q3 is initially at where? Infinity. This is my point of infinity. This is the Q3 charge I have to bring to here. Okay, here if I'll bring a Q3 to be here, this Q2 and Q1 will produce a electric field. That electric field will be opposed because these are all same charges. What is the distance? This distance is R13 and this distance is to be R23. Clear? Okay, so potential we are going to find out work done to bring Q3. Work done to bring Q3 from infinity to the point 3 is equal to potential energy at 3 minus potential energy at infinity. Potential energy at infinity is 0. So potential energy at 3. That is equal to how much? Charge into potential. What charge we are bringing? Q3 we are bringing. So Q3 into potential at the point 3. That is V3. What is V3? V3 is the sum of the potential due to Q1 and Q2. So I can write it as Q3 is equal to 1 by 4 pi epsilon 0 Q1 divided by R13. That is the potential produced by this Q1 at this point plus 1 by 4 pi epsilon 0 Q2 divided by R23. This is the potential produced by Q2 at this point. Clear? Okay. Then now what we are going to do means we are going to find out the total work done. Okay. So the total work done is how much? Total work done is equal to work done to bring first charge Q1 from infinity to point 1 plus Q2 from infinity to the point 2 plus what? Q3 to infinity to the point 3. Okay. This is to be 0. What about this one? That is 1 by 4 pi epsilon 0 Q1 Q2 divided by R1 plus this is the work done to bring third charge. So this Q3 I will going to multiply inside 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus 1 by 4 pi epsilon 0 Q3 Q2 divided by R23. This is the potential energy. This total work done is stored as the potential energy of the 3-point charge system. Clear? From this you can each time you can take it as 1 by 4 pi epsilon 0 outside. Then you can write it as Q1 by 4 pi epsilon 0 into Q1 in Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q3 Q2 divided by R23. This is about the potential energy of the system of charges. Clear? Okay.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like